So let's go over this homework. When we're solving using elimination, the first thing we always want to look for is can we add to eliminate one of the variables? Can we add down the columns? And if that doesn't work, can we multiply one of the equations? So let's see how this plays out. If I look at this first one, when I look down the columns, I notice that my x's are the opposite of each other. They'll add to 0. So that's my decision. I'm going to just add here. And when I add down the columns, the x's cancel out. They add to 0. And I have 6y equals 12. Divide by 6. Y is 2. I'm halfway there. I take either equation. I'll use the second one. Doesn't matter. I'll get the same answer either way. But if y is 2, that would be 5x plus 8 equals -2. Now I'm solving for x, so I want to eliminate the 8. So I have 5x equals -10, divide by 5, and x is -2. What that means is, if I graph these two lines, they would intersect at this point. This is the one point they have in common. Right. Next one. Again, as I look, I notice that my x's are the opposite of each other. So again, I will add. Sometimes it might be the y's that are opposite each other. This happens to just be the x's. And what I end up with is a -1y equals a -1. When I divide by a -1, I get y is 1. Pick either equation. I'm going to take the second one and substitute that y is 1. So I have 2x plus 3 equals 3. I'm solving for x now, so I want to get rid of the 3. And when I divide by 2, I get x equals 0. So again, in alphabetical order, x always comes first in our ordered pairs. If I graph those two lines, that's where they'd intersect. All right. Next one. When I look at this, my x's aren't going to cancel, but I notice they're both a positive 2x. If one of them was a negative 2x, then they would cancel. Again, I can do anything to an equation as long as I do the same thing to both sides. So I'm just going to multiply this first equation by -1. That'll change my positive 2x to a negative 2x, and then they'll cancel. So I get a -2x plus 2y and a -4. The most common mistake on these problems is forgetting to multiply what's after the equal sign too. So important to make sure that you multiply what's after the equal sign. All right. Now I am looking at these two equations. And that's what I'm going to solve. When I add them, the x's cancel. I get a -2y equals 6. When I divide by -2, I get y equals -3. Okay. Now I'm substituting, and again, I can choose either equation. I just pick the one that maybe looks the easiest, and I put a -3 in here. Oops. So I have 2x, a -2 times a -3 is a positive 6. I subtract a 6 from both sides because I'm solving for x. divide by 2, and I get x equals -1. And so my answer is -1, -3. Right. Go to the next one. When I look at this, adding down the columns isn't going to eliminate one of the variables. But I notice the 4s. One's a positive, one's a negative. I mean, they're both negative. If one was positive and one was negative, then they would cancel. So I'm going to multiply one of these by -1. That'll give me a -1x, a positive 4y, and a positive 6. Again, I need to remember to multiply each part by -6. All right. Again, now I'm dealing with these two equations. When I add, I get a -5x, the y's cancel, and I get a -10. I'm solving for x, it's multiplied by -5, so I divide by -5 and get x is 2. I'm going to pick either equation to simplify. I'll just take the first one. And I'm going to put x is 2. So this is 2 minus 4y equals -6. I'm solving for y, so I need to move the 2. I have a -4y equals a -8. Divide by -4. Y is 2. And my ordered pair here is 2, 2. If I graph those two lines, that's where they would intersect. All right. Looking at my next one, when I look down the columns, these aren't going to cancel, these aren't going to cancel, y's aren't. And it's not like the previous problem where like they were both the same number, a positive 4x and a positive 4x. So that's, I can't just multiply by a -1. So here's what I have to look at. And I have two choices. If I wanted to eliminate the x's, this is a 4x, I would need this to be a -4x. So that means I would have to multiply it by 2. All right, that would give me a -4x, a positive 6y, and a -16. Okay. And now I would be dealing with these two equations. When I add down the columns, the x's cancel. I have a positive 5y equals -10. Divide by 5. Oops, y is -2. And then use either equation. And y is -2. So I have -2x. I have 3 times -2. That's -6. I need to solve for x, so I need to eliminate the 6. I have -2x equals -2. X is 1. So my solution, if I graph these two lines, they would intersect where x is 1. Oh, great. I wasn't showing you that. Sorry. I'll do a better job here. All right. When I look at these, if I want to eliminate the y's here, I need a -6 and a +6, which means I would have to multiply this second equation by 2. So I'll rewrite the first one. And then I will multiply the second one and I get 10x, positive 6y, which is what I wanted, -28. And the way I set it up, these guys will cancel. So I'll have 4x, this cancels, equals -16. Divide by 4, x is -4. And then I go ahead and substitute in either equation. So I'll take the second one. 5x plus 3y equals -14. And now I'm going to substitute that x is -4. So 5 times -4 is -20. I'm going to add a 20 to both sides. I'm looking to see if I made a mistake here. X is -4, -20, add 20. No, I'm good. 3y equals +6. Divide by 3, and y equals 2. So my ordered pair here is -4, 2. Again, if I graph those two lines, that's where they would intersect.